Hello, guys. How are you guys? Solomon Harris, Nathan Light, Queen Hart, Bill Hostetler, nice to see you again. Good. Margie, Paul, Rodrigues, then Ilyas, Tyson, Nick, Alex. All are present, right? Is anybody left out? No. Okay, guys. My first question is, have you gone through the stuffs what we covered yesterday?
Yes, sir.
Sir.
All of you, be honest. If you have not gone through it, please let me know right now. Be honest. Nina?
I did it, sir.
Good. Ilyas?
Yes, sir.
You did?
Yes, sir.
Nick? Yes. Queen Heart? Yes. Looks on your face. Yes, I know. Then let me go through Will Hostetler.
Did all of it, sir.
All of it? Are you sure?
Well, I did 1 through 3, all of it, because we haven't finished going over 4 yet.
Oh yeah, I know. But
all that I could. Oh yeah.
Good. Nathan Light.
I did it.
I can't hear you.
I did it.
You did it? I get. Harris?
Yes, I finished 1 through 3 as well.
Paul is good. No, 1, 2, 3, but I told you to go through at least 2 examples, whatever we covered yesterday for 4th example. Did you go over those 2 examples?
I went over everything we went over in class, but I was just saying I finished 1 through 3 on the practice test too.
That's always the problem with you guys. I told you to go through those 2 problems, but Alex?
Yes, sir.
Right? Good. And Will, you also, right? You also go through, I just went through 1, 2, 3. Not those 2 examples I took yesterday in the class.
I looked at the ones in 4 too. I just didn't finish 4 because we don't know how to do all of it yet.
Okay.
So.
No, all of you, again, listen to me carefully. I didn't ask you to go through all the examples. I just asked you to go through just 2 examples, what I covered here in the class, for example 4. I did not ask you to go through other examples. No. Did I? No. I just want you to only go through those 2 examples, which I took it here in class. Did you go over those 1? Will? No. Right? You did? Oh my gosh, that's good.
Yeah. 4C and 4D. Boom.
That's what I want. Thank you so much. Margie?
Yeah, I went through a portion of it. Sorry, I'm in a car right now.
Where are you going?
I'm driving back to Virginia. My brother is.
So are you driving or you are? No, you're
I'm
on the side.
right now,
Okay.
but I'm almost there. So.
Okay. Okay. Once you reach over there, let me know. Okay.
Yep. Yeah, I'll stay on the call though, because I have paper and a pen with me.
I can't hear you. What you said?
I'm staying on the call though.
Okay. Then who is left out? I think Ismail. Taylor?
Yes, sir.
Yes. Did you go over the things we did yesterday?
Yes.
Are you sure? I'm doubtful. Are you sure?
Yes, I'm sure, sir.
Then it's okay. Okay, so let me share my files and then after we can go over the new stuffs, right? Just wait. Okay. Nope. What I am doing, I don't know. And desktop, right? Online lectures, okay, 124 per 8 and so on. Okay, guys, so method of undeterminate coefficients, right? Just give me a minute so that I can start this one. Why I'm not able to share my screen? Something. Okay. Is it the one? No. No, sorry. Class notes, chapter 4 PDF. Makes sense. Minimize this one. Minimize this one. Share my screen. Huh. What's wrong with this one? Okay, got it. Can you see my screen?
Yes, sir. Yes, sir.
Yes,
Can you
sir.
see my screen? Okay, so yesterday, we went over this method of undeterminate coefficient, this example. And then after I took one example in which we had a glitch, and I just wanted you to go through that glitch part. Hopefully all of you or most of you have done this thing. That will make today's class very easy, comparatively easier than the yesterday's class. So question number 4b, second example, y double dash minus 2y dash minus 3y equal to 4x minus 5, 6x e to the power 2x. Before I start this example, let me remind you, you are taking your next exam on Friday, day after tomorrow. You know this thing, right? So please, I'm going to finish your syllabus tomorrow morning, and then after first hour, syllabus will be done. And then immediately after that, we will start the review session. But review means you need to go through all the examples given to you in the practice test assignments. You have the answer key and everything, try to solve the examples, because if you stuck at some point, review is the right time to discuss those examples over here to take the help from me or somebody else. There's the really, really good time to review. But unless you go through those examples, you will not be having any problems. And that's why there's no point of review. See, if I find that you guys have not gone through the examples or you've not worked hard today, probably I need to cancel the review session. So it is up to you. If you want me to continue with the review session, you need to go through all the examples. If you have some problems, I'm here to help you out. If you're stuck at some point, but first of all, I will ask you, what is the problem? Where you stuck? What is the difficulties you are facing? That's what I would like to know first, so that I can clear your doubts immediately. So that is the purpose of review session. So please do this thing. Without fail, please do this thing, because today's hard work will pay you tomorrow. I mean to say that if you are going to solve all the examples of practices today, tomorrow your work will be really, really lesser comparatively today, and you will be good at the time of the exam. So instead of working just last night or before a day, I think it would be really good to work at least before a review session. That is just the advice. Good. Y double dash minus 2y dash minus 3y equal to 4x minus 5, 6x e to the power 2x. You can see over here, this is first example, that is, I mean to say right hand side, that is nothing but the combination of two functions. One is the linear function, polynomial, and the second one is the product of the x algebraic function and the exponential function. So this is the algebraic function and this is a product. Now both parts are different. Guys, please pay attention here. How glitch works, that is more important. If glitch is there or glitches are there, you have to be careful which portion of your example creates the glitches. It's not like this that the whole part will create glitch every time. No, sometimes it may possible that only this part will create glitch. So you are not supposed to change any, and you are not supposed to make any change over here, or vice versa. Suppose this part is creating some kind of glitch, and this part is not affected at that time. So just keep that part as it is. Keep that part as it is. That is most important, that which part creates the glitch on your right side. Left side is quite easy. Y double dash minus 2y dash minus 3y. So if you write the operator form, so it is d square minus 2d minus 3 outside y equal to 0. So auxiliary form is m square minus 2m minus 3 equal to 0. Simple factors, m minus 3m plus 1 equal to 0, so m equal to negative 1 and 3. Roots are real and distinct. Because roots are real and distinct, we have ycx equal to c1 e to the power negative x plus c2 e to the power negative plus c2 e to the power 3x. Article 4.3, 4 rules. First rule over here, roots are real and distinct. Now, my assumptions of yp. I gave you the formula sheet yesterday and told you keep your formula sheet handy every time. And I know most of you have not followed me. Still you have time, do it. Yp equal to ax plus b, because this is a linear function. That's why I wrote it down separately. Look at over here. It was just one function, but I make this bracket like this to let you know that we are working with two separate functions. We are working with two separate functions. Okay, so here it is. Because 4x plus 5 linear power is 1, so I have to assume the general form ax plus b. It's a product of x and e to the power 2x, some kind of x, I think formula number 9. So here you can see linear power with exponential function. Linear power means again it is ax plus b, but already I chose ax plus b for the first part. Let me choose another two constants cx plus e. We don't write d, you know it. If you write d, you will get confused. Don't use d particularly for the method of undeterminate coefficient, because d stands for an operator and all these a, b, c, e, all are constants. So please make sure. Ce plus e to the power 2x. That's how formula number 9 says that we have to assume my yp. Now look at here, guys. My yc contains the exponential function, and I don't have any exponential function related to my first part. So I'm not going to touch this part because this is without exponential function. So this doesn't create any kind of glitch. So just forget it. But the second part, c2 e to the power 3x. c2 e to the power 3x. only this e to the power 3x. See, cx plus e, that was the combination. I got it from the second part. Please, guys, please pay your full attention. Cx plus e, that is a combination. I don't write this cx times e plus e times e because this is the whole combination I'm getting from the second part. And that's why e to the power 2x. If I count only this part, e to the power 2x to get here. E to the power 2x. So this e is a constant, e to the power 2x. C2 is a constant, e to the power 2x. That means this creates a glitch with this one. Sorry. Oh, it is 2x and it's 3x. My bad. I'm sorry. It is 2x and it is 3x. It looks like that this is e and here it is C2 constant, but my powers are different. Here it is 2x, here it is 3x. So no glitch. Right? No glitch. You're absolutely good to go. Go for the second derivative because your second highest derivatives over here on left side. So yp dash is a product rule over here. Take the derivative. Don't say you don't know derivative, please. So yp dash, simplify this one. Go for yp double dash. I did the second derivative. yp dash and yp double dash. Yp dash means this second part, expanded form. Plug all these three values here in your left side and right side as it is. So that's what I did. Or put my all three values over here. See, it's a long expression. Most of the times you will be getting such kind of long expression. Most of the time you will be getting such type of long expression here to here. That is equal to 4x minus 5 plus 6x e to the power 2x. E to the power 2x. Okay. Good. Our intent is to write my left-hand side in the proper form so that I can compare my left and right side. Here it is x to the power 1, so I can consider x to the power 1, but before that I have x e to the power 2x. So let me collect x e to the power 2x over here on my left side. I have 4c x e to the power 2x, x e to the power 2x. This is plus and minus will get cancelled out. Fine, sounds good. 3c constant, negative 3c constant, x e to the power 2x. Let me keep this part first. Then after, let me collect only e to the power 2x. I have e to the power 2x over here. Here, first term. Second term, e to the power 2x is there with constant. But I have negative 4 and positive 4, so this will get cancelled out. And I have this is negative 2c and here positive 2c. So ultimately, I'm going to get positive 2c. So positive 2c e to the power 2x. You have to be very careful, particularly for your calculations. Otherwise, the whole example will be wrong. Mainly this part, your derivative and this part. That's the only important thing. Then after you have e, there is no any more e. So e, 3e e to the power 2x, 3e e to the power 2x. And I have 2c and 3e, right? So x and e to the power 2x, all these terms are done. Now let me go for x to the power 1. X to the power 1, I am having over here this constant. Always I put different signs over here. See, curly sign, single line, double line, circle, so that I can come to know that I'm just collecting my constants. See, negative 2 and negative 3, these are the constants. So I just put it down over here. Then after I want linear power, you can find x to the power 1, and that's why I use another bracket over here. So you can use this symbol, different types of different kind of symbols, and that will make you not to make any mistake. That will help you not to make any mistake. So negative 3 of 3ax, that's the only x power. So let me write down over here. And right hand side is as it is. If you compare your left and right side, you're going to get, look at here guys, your left and right side. So x e to the power 2x is, here it is 6. So I'm getting my first equation, negative 3c equal to 6 means c equal to negative 2. Or you can write negative 3c equal to 6, that's fine. My second equation, e to the power 2x, I don't have simply e to the power 2x over here. It is with x, but simple e to the power 2x is not there on the right side. So this is 0, 2c minus 2 equal to 0. You are getting value of c over here, just plug it over here so that you will be getting value of e very easily. Third one is negative 3a equal to constant term, coefficient of x, negative 3a equal to 4. So a equal to negative 4 third. Finally, negative 2a minus 3b equal to negative 5, constant term. Already you are having value of A. Just plug the value of A over here so that you will be getting value of B. So you will be getting all these values A, B, C, D just by simple calculation. So you don't have to go through matrix. But otherwise it is your choice. If somebody wants to use the matrix over here, that's his or her choice. That's fine. That's fine. You can use that thing, but you make sure after RREF, you must get the same answer. Okay, so I'm getting all my A, B, C, and E. So A, B, C, and E. Look at over here. I just plug the values. A, B, C, and E. YP equal to this one. Finally, don't forget Y equal to YC plus YP is your general solution. So this YC is this one, and YP is this one. That is your general solution. So YC plus YP is the general solution. Please make sure. YC plus YP. And this is not enough, guys. I'm just explaining to you. That's why this is enough for me, but not for you. You have to plug the values, YC and YP. Please plug the values. I'm giving instructions to you guys. This is fourth time probably since yesterday. But even though some of you will make the mistake, they will not plug the values and they will leave this thing for me so that I can cut your 1 or 2 points. Okay, choice is yours. Okay, I think this is just the repetition of the same example, so I don't want to go through this one. But yes, repetition of same example. Let me skip that part. Method of undeterminate coefficient. We know we are doing the same thing. Okay. Again, the same example, guys. I think there is no glitch in this example, because if you take the left-hand side auxiliary equation m square minus 4m minus 2, you are getting negative 2 plus or minus root 6. I think we did this example yesterday. So there is no glitch. Just follow this example and you will be getting this one. Yesterday, I solved this example for you guys. Y double dash minus 2y dash plus y equal to e to the power x. I solved this one on the whiteboard. Let me revise this example for you. Auxiliary equation is m square minus 2m plus 1, m minus 1 whole square equal to 0. So m equal to 1 and 1. Please make sure, don't write just m equal to 1. Second order equation, you have to have 2 roots. Roots are real and same, real and repeated. So yc is c1x plus c2 e to the power x. Or you can write c1x e to the power x plus c2 e to the power x. My yp, according to my e to the power x on right side, my yp assumptions would be my yp assumptions would be a e to the power x. A e to the power x. Right, guys? So naturally, this a is a constant e to the power x. This creates a glitch with the second part, c2 e to the power x. That means our method says that we have to multiply our equation by x, our right side by x. So let me multiply by x. If I multiply by x, I'm getting the glitch over here with the first part. Let me multiply by one more x to get rid of this glitch. So ax square e to the power x and no glitch. You have to mention this thing, guys, whatever I did over here, arrows, glitch, no glitch in your exam. I don't want to hear this thing that I counted in my mind. No, I can't read your mind. I just want to read your whatever you are going to write on your page. So please make sure, guys, please. Then go for the first derivative, because now this is out of glitch. So we are taking the first derivative over here, second derivative over here. 2 derivatives are there. Second is the highest derivative on my left side. So that's what we are doing over here, right? And then plug it back. On my left side and right side is e to the power x. Again, you can see over here, this 4a e to the power x and negative 4a x, this will get cancelled out. See, I use this one. Then I use some curly lines like this, because this get cancel out. See, ax square and ax square, 2ax square and negative 2ax square. Finally, 2ax square equal to e to the power x, right side is left out, so a equal to 1 by 2. Plug it over here in your non-glitch part, please. You cannot use that any kind of glitch. Non-glitch part, just plug it back over there. And finally, y equal to yc plus yp, and these 2 ticks means plug the value of yc and yp. And that is the answer. That's why I leave it for you. We repeated, we did this example yesterday. Now, good. One more example. Example number 4e. I'm providing you everything, guys. I gave you the solution keys, and I'm giving you almost 95% of the solutions. Yes, example number 4E. Nice example. Nice example. Why nice? I will let you know. Very slowly, look at here. Y double dash minus 6y dash plus 9y equal to 6x square plus 2 minus 12 e to the power 3x. Again, I can divide this example into two parts. 6x square plus 2 is my polynomial, second order polynomial, and 12 e to the power 3x, that is my exponential function. So this one is separate, this one is separate. Agree? Here I have not put any bracket because now I want you guys to understand the problem correctly without my help. So previous example, I put the bracket so that you can bifurcate your functions, or you can look at your functions into two different ways, two different parts. Here also you can do the same thing. Quadratic function for this one, and then exponential function for this one. Good. So naturally, my left hand side is auxiliary equation m square minus 6m plus 9 equal to 0, perfect square, m minus 3 whole square equal to 0, m equal to negative 3, sorry, m equal to positive 3 and positive 3. Roots are real and repeated, so c1 e to the power 3x or c1x e to the power 3x and c2 e to the power 3x, right? Any one of the constants is multiplied by x. Now my yp, assumptions of yp, first part here to here is my quadratic equation. So according to my formula sheet, I have to have ax square plus bx plus c for my 6x square plus 2. Ax square plus bx plus c, and I put the bracket because I'm writing just for first term. Plus no e. One more thing, guys. Even though here it is minus, always take plus sign, always. If somebody says that, no, I want to stay with minus, that's fine. But don't make your life more complicated. It's just constant. You can play with the constants. So many times I've been telling you. So this is, even though minus, you can write plus and you will be getting the same answer. Don't worry. Yep. So plus, no d, e to the power 3x is e, actually a e to the power 3x. But we already used a, so let me put another constant e, small e to the power 3x. And as you know that once I assume my yp, I have to compare that one with my yc so that I can try to figure it out, my glitches. My yc, if you see here, they are of the form, exponential form of power 3. So naturally, my first quadratic part of assumptions of yp is not affected because exponential function is there. We don't have any exponential function here, any kind of. Okay, good. But C2 is E, C2 is constant, E is constant, e to the power 3x. This portion only creates the glitch. Look at over here. Only this portion creates the glitch with my YC. Multiply only this portion by X, not the full YP, please. Otherwise you will be wrong. The part which is not affected by your, or not creating any glitch with your YC, if you multiply that part by C, you will be wrong because that is always out of glitch. And again, you are multiplying means you are going to go for some other function. So only this part is multiplied by X, just one X. Okay. I did it directly. Just avoid it. Just consider here EX e to the power 3x, EX e to the power 3x. But if I multiply by 1x, EX, that creates the glitch with this part. Actually, I should have mentioned this thing. You have to. If I multiply this only by x, because that created a glitch with this one, so multiplying by x, it now creates a glitch with the first part. That means one more multiplying by x, so ex square. And there is no x square terms over here, so now it is out of glitch. Now it is out of glitch, take the derivative. Second derivative up to, you need to go. So 2ax plus b, product rule over here. So 3ex square e to the power 3x plus 2x e to the power 3x. Yp double dash, again product rule over here and product rule over here. So this is the expression. plug these without glitch part, this one, yp, yp dash, and yp double dash, these three here in the equation. Make sure that you are writing every term without missing a single one. And your right side, this one. Once you do this thing, then after you will be having, look at over here, if you compare the coefficients, first of all, I wrote it down this thing in the form of course you can write anyway, but ex e to the power 3x gets cancelled out because here it is 6, here it is 6, right? So it is 12 and 6ex e to the power 3x and 12, 6 and 6, 12. And then you have negative 12 ex e to the power 3x. So you can see these curly lines, all these factors are cancelled out. Okay, 9ex square and 9ex square, 9 plus 9 is 18 and here is negative 18, so that will get cancelled out. That will get cancelled out. Okay, so what is left out now? Left out part is 2e e to the power 3x, negative 12ax, and that's the only part, negative 12ax, 9ax square here, 9bx. Okay, so 12ax and 9bx, you can combine 12ax and 9bx. You can combine these two and take your x out and constant terms together. If you do like this, you're going to get, here I have used some calculations, but you are not supposed to do this thing. You can use matrix because there are 4 or 5 constants now. So if you compare your coefficients to equal to negative 12 e to the power 3x coefficient, so equal to negative 6, that's fine. Otherwise, just stay with this equation. 9a equal to 6, so a equal to 2 by 3. 12a or negative 12a plus 9b equal to 0 because there is no x power here, x to the power 1 here. So b equal to 1 by 8 just by plugging this value of a here. Plug this value of a and b over here in the last equation and solve for c. You're getting c here. So many times it's just simple without using your matrix. Otherwise, you can convert this 1, 2, 3, 4 equations in the matrix, use RREF and get the answer. So finally, see here, I solve by both ways. A is 2 by 3, B is 8 by 9, C is 2 by 3, E is negative 6. And if somebody says that, no, I want to use the matrix, finally, YC equal to YP, just plug the values over here and you get the answer. You can write your equation in this form. Your first equation is simply 2E equal to 12, negative 12. That means A coefficient 0, B is coefficient, C coefficients are 0, and 2 equal to 12. So you can write like this. So these 4 equations. It doesn't, I'm going to say, whatever you are writing over here, please make sure that if you want to interchange, see here, I have my first equation, this one, and second, this one. You can write this one as last, this one as third, this one as second, this one as first. It's up to you. Order doesn't make any difference. So if you write like this, and then, oh, sorry. And then use RREF, you will be getting this one. So my A equal to 2/3, A equal to 2/3, B equal to 8 by 9, blah, 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 C equal to 2/3, E equal to negative 2. Go back and plug it there in your assumption YP. And finally, Y equal to YC plus YP, plug both of these values. So that is the answer. So I think, guys, yeah, this way I solved almost so many examples. Again, repetition of some of the class notes. Yeah, just for you guys, if you want to go through this one, that's fine. Otherwise, it's just the repetition. We did this example yesterday too. Again, both ways, matrix and simple algebraic calculus too. One more example, and probably the last example for method of undeterminant coefficient. Last example. Looks very big example. Look at over here, but it's a simple example because that you are not getting any glitch over here. Auxiliary equation is m square minus 8m plus 20 equal to 0. So m equal to negative 8 plus or minus b square minus 4ac divided by 2. Roots are complex conjugates. So e to the power, case number 3, article 4.3, rule 3, e to the power 4x c1 cosine 2x plus c2 sine 2x. Yp quadratic function ax square plus bx plus c for first part, just first part. 100x square is ax square plus bx plus c, this one. This is a product of two functions. So x e to the power x, linear function, linear algebraic function is multiplied by the constant exponential function. So ex plus f e to the power x. You can see over here, here it is e to the power x, here 4x. That means no glitch. This term is independent of exponential function, so no glitch. Second derivative, first and second derivative, plug it over there in the equation. You are getting like this. Because it's a big expression now, I think it is advisable to go for the matrix, but your choice again. Usually I do it by hand because it's equally same time for me. So just try to compare the coefficients and you are getting ypx equal to like this. Just plug it back in your general solution, y equal to yc plus yp. Plug it over here to get your full answer. So I saw a number of examples for you guys. Whatever the examples are not done, just do it yourself. Whatever example solutions I gave you, that doesn't mean that you don't have to solve those examples. You have to go through each and every problem of the practice test correctly, nicely, good handwriting to claim full points. So that is all about the method of undeterminant coefficients. I think it's the same thing again. Oh, why I took this page again? Let me skip that part. Okay, slightly different. In the previous example, if you remember, I took it over here plus. All of you now pay attention. I took it over here plus, but now I just slightly changed. Plus is replaced by minus, otherwise exactly same. Everything is exactly same. Look at here. But this plus and minus makes a big difference in your solution. Method, everything is different now. This plus and minus makes a big difference. M square minus 8m minus 20 equal to 0, auxiliary equation. The roots are now, it was plus over there previously, so I used some quadratic formula, but now you can use directly the factors m minus 10, m plus 2 equal to 0, m equal to negative 2 and 10. So roots are here and distinct, so y is c equal to c1 e to the power negative 2x plus c2 e to the power 10x. First function, quadratic function, my assumption is related to ax square plus bx plus c for this one. And product function, I don't bother about this negative sign, fine. So plus sign, because it is x, formula number 9, ex plus f, x to the power, say ex plus f, because actually ax plus b, a and b are already used. So ex plus f e to the power x. Now, again, you can see over here, ex plus f, because here power is negative 2x and 10x. So no glitch, right? Because powers are different. First part is already different from this one, so no glitch. And you can proceed further. Just you need to take care of your calculations. Some big numbers are there, so use your metrics accordingly and avoid the mistakes. I think this example is also very easy, so you can do this thing too, because it's exactly same. E to the power x, I think we did this example. This is again the second time. Let's go through this one. Yeah, oops. Just cancel this page. So I think I saw a number of examples, right guys? And now we are going to see method of variation of parameters. Method of variation of parameters. Right, oh, again, no, it's okay. Yeah, in this example, guys, look at over here. Only this e to the power 3x is creating glitch with this one. But this e is not separate. This cx plus e whole function came from your second part. That means you have to multiply the whole function by x. Don't multiply just by e by x. Otherwise, cx plus ex, again, it will be wrong. So you have to write, you have to multiply this one by x, so cx square, and here it is ex. Whole function is multiplied by x, like this. So please make sure. First part is separate. First part came from the first one, polynomial, and it is not affected by this YC, so no glitch. But this E is only affected over here, but that doesn't mean that you can just multiply by E. No, whole CX plus E came from the second part. So you have to multiply the whole CX plus E. So please make sense. Please make sure, please. Rest of the things are just repetition. See, 4 equations are there. I just solve both ways for your convenience so that you can choose any one of these 2 methods. Usually I prefer matrix if I have more equations, more constant, I mean to say A, B, C, E, F, something like that, 4 or 5 constants. I prefer to go for matrix to avoid the mistake. Second last article of this chapter, method of variation of parameter. Mainly for second order differential equation, guys. Look at over here. A2y double dash plus A1 xy dash plus A0y equal to gx. Second order differential equation. Just like your article 4.1, when you were out of 2 solutions, one solution was provided to you and you were looking for the second solution. If you remember, we took the coefficient of the second derivative 1. Exactly same here. You have to have the coefficient of second derivative 1. Here coefficient is A2x in general, so just divide by A2x throughout. If you divide by A2x throughout, don't forget the right side, please. Throughout means throughout. You are going to get y double dash plus px. This is my pxy dash plus qxy equal to fx. So up to here, it is exactly same as your article 4.1. Now, once you are writing your equation with highest derivative coefficient 1 or second derivative coefficient 1, then after go for auxiliary equation. Find the auxiliary equation, take the factors, solve it, and you are getting ycx equal to c1y1 plus c2y2. Then you find the Vronsky. Vronsky W is nothing but whatever you are getting, now guys please pay attention, whatever you are getting here, y1 and y2 in your complementary function, use same y1 and y2 here and your derivative. y1, y2 and its derivative. And then use, once you find this Vronsky, then use this formula. yp equal to negative of yp integration y2 fx divided by w plus y2 and integral y1. See, y1 and y2 are interchanged now. You started with y1, here it is y2. You started with y2, here it is y1. W and w. W is Vronsky. Fx is nothing but your, fx is after dividing by your coefficients of y double dash, whatever you are getting, that is your fx. Don't count your fx as a given function. Now your main function is this one. So this is my fx. This is my fx. Okay. So just plug the values and you are done. And this is the formula. If you refer the book, he has separated out lots of things and he has not given this formula to you. And if you refer the book, probably you need to work for almost 1.5 pages to find the solution. But if you follow this formula, you will be ended up in 3, 4, 5 steps. Just 2 steps, I would say. The rest of the things are just integration. So I would say just 2 steps. That is the advantage of this formula. I told you I'm going to provide you this formula. This formula, this YP, is written in your formula sheet, bottom part. Last formula I gave it to you. Method of indeterminate coefficients, your assumptions of YP, and at the bottom part of that page, this formula for variation of parameter is written down. One more thing, I told you that method of variation of parameter you can use only when it is asked to you. That is mainly for second order differential equation. Suppose your right hand side equal to tangent x, secant x, something like that, or some combination of secant tangent like this, cotangent. At that time, it is preferable to use that one. Because if you look at article 4.4 formula sheet, method of undeterminant coefficient, formula sheet, all my YP assumptions, not a single one includes tangent and secant form. So tangent and secant form mainly for tangent and secant, this type of form, I would say that probably variation of parameter is more useful. Okay, let me start with the first example. Pay your full attention. Pay your full attention. Just give me a minute, guys. Look at here. This is again question number 5 here from your practice test assignment. Right? So I have provided you the answer keys. I am providing you mostly 95% of the solutions too. And anyone can expect just 5% from you guys. And if you think that you cannot do those 5% too, I would say that probably you are not the right person for this course. Right? Anyway, I'm just kidding you. So m square minus 4m plus 4 auxiliary equation. You can see my coefficient of y dash, highest value is 1. So I'm good to go. Let me find. This is my fx. This is my p. Don't forget to consider minus sign with p, because your formula says plus here. So you have to consider this minus with p and q. We don't use q, just like your article 4.1. We don't use q. Auxiliary equation m square minus 4m plus 4 equal to 0, m minus 2 whole square equal to 0, perfect square. So m equal to 2 and 2. Don't say only 2. 2 and 2 is a real and repeated roots. Because real and repeated roots means article 4.2, rule number 2, c1 e to the power 2x plus c2 x times e to the power 2x. If you compare with this formula, I told you that whatever you are getting is y1 and y2. This y1, whatever you are getting over here, one part is y1, second part is y2. Keep your constants out, because we require this thing in the Vronsky. So you can see over here, oh my gosh, I would say that my y1 is e to the power 2x, my c1 out, my y2 is x times e to the power 2x, c2 out. Look at here. Then I find Vronsky, y1, y2, y1 dash, y2 dash. y1, y2 as it is, derivative 2 e to the power x, power rule. Here it's a product rule, x as it is, or derivative of x is 1, e to the power x, 2x as it is, x as it is, e to the power 2x, derivative is 2 times e to the power 2x. Cross multiplication, you know how to solve the determinant. Cross multiplication, e to the power 2x and 2x is 4x, 2x e to the power 4x. This side it is minus sign, so negative 2x e to the power 4x. This will get cancelled out. Vronsky is e to the power 4x. Your Vronsky is e to the power 4x. Let me use my, what is this? What is this by 4e? I'm working with 5a. Do you find anything below this one? I think something is wrong. I took the wrong printout of the page. I mean, it's a scanning of the pages. Probably it will be the next page. Yes, it is here. See, don't count this page, guys. Otherwise, actually, I need to scan like this. Front part and the back part, but I did the other way around. The back part and the front part. So just skip this example. Skip this example. Example 5. Not this one. This one. Right? Or question number 4e. One more example I did for you. You can refer that one. Let me continue with this one, the previous page. So once I found my W Vronsky e to the power 4x, then after, next page is this one. Plug the value in the formula. Yp equal to negative of y1. y1 is e to the power 2x. y2 is x e to the power 2x. Right hand side fx is x plus 1 e to the power 2x divided by Vronsky e to the power 4x. Plus x e to the power 2x. Now my y2. This is my y1. my right hand side fx, Vronsky e to the power 4x. Everything that is in product and division, you can cancel it, common things. You can cancel common things. Here x and x plus 1 is left out. Product gives you x square plus x. Here x plus 1 is only left out part. Power rule term by term integration will provide you x cubed by 3 plus x square by 2. Here it is x square by 2 plus x. So this is my yp. Whatever yp I'm getting, plug it back over here in my general solution, yc and yp. That's a general solution. That's it. Somebody may argue like this, that suppose I want to use the first method for this example. Will I, could we get the same answer for this example if I don't use method of variation of parameter? Answer is yes. If you take this one, if you assume your yp accordingly from your formula sheet, and if you follow the article 4.4 undetermined coefficient, you will be getting, and if you try to take care of your glitches and everything, you will be getting the same answer. Same answer. Okay, guys? So unless, I repeat, unless it is asked to you, don't use this method. In the examination specifically, I'm going to ask you, use the method of variation of parameter to solve this example. So you have to use that method only when it was or it is asked to you. Okay, guys, I think sounds good. Let's go for one more example. Example number 5. A is done, B is homework. In example B, I think coefficient is not 1. So please divide first by is something 4 y double dash, something like that. So just divide by that number and then you can start with the example. In example 5C, coefficient is only 1. Auxiliary equation is m square plus 4 equal to 0. So m equal to plus or minus 2i means it is alpha is 0, alpha plus or minus I times beta. Roots are complex conjugate of each other. Rule number 3, article 4.3, ycx equal to c1 cosine 2x plus c2 sine 2x, because e to the power 0 is 1. This cosine 2x I would like to write as y1. The second part I would like to write as y2 and plug these values in a Vronsky. Take the derivatives of my y1 and y2 and then go for cross multiplication. You're going to get 2 cosine square 2x plus 2 sine square 2x. 2 common, cosine square plus sine square is 1 because 2x is an angle. So 2 common times 1 is 2. So Vronsky is 2. Use the formula, plug the values in the formula for yp. Negative of y1. y1 is cosine 2x. Under the sign of integral, y2. y2 is sine 2x. Right hand side is 4 secant square 2x. So 4 secant square 2x, that is my fx because of coefficient 1. Divided by Vronsky 2. Plus, other way around, y2 out, y1 in, fx 4 secant square 2x, Vronsky is 2, and dx. Cancel the common things, 2 to the 4, same here. Negative cosine 2x is out. This 2 is constant. Let me pull it out. This 2 is out. So what is left out here? Secant 2x and sine 2x and secant square can be written as cosine 2x. Secant square is secant times secant. 1 secant 2x I would like to write in the denominator as cosine 2x. Second secant 2x, because square is there. Second secant 2x, I would like to write it down as it is. Why? Because tangent and cosine, tangent over cosine gives us the, sine over cosine gives us a tangent. And you know that tangent 2x and secant 2x form you're going to get. Tangent 2x and secant 2x. Plus 2 sine x, just take this 2 out, cosine 2x and secant square 2x. Cosine 2x, secant square, 1 cosine I would like to write, 1 secant I would like to write as a 1 over cosine 2x. This will get cancelled out, so only secant 2x is left out. Here you can use u sub or something like that. Oops, sorry. That negative 2 cosine 2x. And here it is integration of secant x tangent x is, what is derivative of secant x? Secant x tangent x. So integration of secant x tangent x is secant x. Angle is same, 2x. So secant 2x divided by 2. 2 sine x and integration of secant 2x. Again, formula said ln of absolute value of secant x plus tangent x. Ln of absolute value of secant of 2x plus tangent of 2x divided by 2. Right? Don't forget dividing by 2, please, because 2x is your angle. Or otherwise, you can do like this: secant 2x dx, take first 2x equal to u and then apply the formula. Otherwise, you will miss this 2 in the denominator and you will be wrong. This 2 and 2 will get cancelled out. Left out part is sine 2x. Whatever is left out, that is your yp. Plug it back in yc plus yp. That is the general solution. Don't forget to put the values of yc and yp. So that's what we have done for our method of variation of parameter. Method of variation of parameter. 5a again, repetition. Let me skip that part. Okay. 5b also I have solved. Look at here. So 5a, b, c, d, 4 examples I gave it to you. Out of these 4 examples, already I have solved 3 examples. There is a third one. 5a is done, 5c is done, 5b. You can see here my coefficient is 4. So first of all, I have to have the coefficients of the highest derivative 1. So divide by 4 throughout. Don't forget to divide over here. This is my fx. Auxiliary equation m square minus 9 equal to 0. So m equal to plus or minus 3i. Complex conjugate root. Rule number 3. c1 cosine 3x plus c2 sine 3x. Cosine, or you can write c1 sine 3x and c2 cosine 3x. I don't mind. It's up to you. Right? So first one is known as your y1. This is y2, Wronskian. Just simple determinant, that is 3. Plug it back over here and you are getting negative of y1 and y is the formula. Plug the values of y1 is cosine 3x, y2 is sine 3x. Right hand side is 1 by 4. So don't forget this 1 by 4, 1/4. Take this constant out, 112 out, and integration of 1 is x sine 3x, 112, 4 times 3, 112 out. Cosine 3x, secant is sine over sine, cosine over secant is cotangent, or you can use cosine over sine is cotangent, or you can use sine 3x equal to u. So du equal to 3 cosine 3x, c cos 3x. Right? And finally, u equal to ln of u. Plug the value of u, that is your. Don't forget this 12 times, if you use this du, you're going to get 1/3 outside, so 36. That's what the answer I provided to you. The general solution is yc plus yp plus the values. Oh my gosh, and I solved the last one too. So all 4 example solutions are there with you guys. Last one is also there, e to the power t tangent inverse of t. So please try to convince yourself. I don't want to go through each and every problem. This question number 5D also. If you find some problem in question 5D, let me know. I will solve this example for you tomorrow. But right now, I just want you to go through this one or do this example by your own. And integration may give you little hard time, little pain, if you are not good at integration. If you are good at integration, sounds good. You won't face any problem. So that is the second last article, and the last article is simultaneous linear equations. Question number 5D, A, B, C, D. How many examples I did? Number of examples, right? Again, same repetition. Article 4.8, that is the system of differential equation. System of differential equation. What do you prefer, guys? If you want, we can start this article tomorrow, or if you want, I can take this article today. Otherwise, tomorrow, first 30 minutes, we will go through this system of equations, and then we'll start the review session. Or I can teach you right now, and tomorrow, just 1 hour review. It's up to you. Decide.
Sir, could we go over it tomorrow?
Who is there?
Yeah, I would like that. They're giving me more time to work on the problems today.
Yeah, I feel like it'd be kind of overwhelming today if we had all like 4, 5, and 6 that we've gone through versus now we can just focus on the rest of 4 and 5.
Okay, I don't mind. Only thing is, what do you
Agreed.
guys say? Harris, Nina, Gage Levine,
I'm
That's fine
fine
with
with
me.
that, sir.
tomorrow?
Yes, sir.
Tomorrow.
Yeah,
Yes,
we're
sir.
winners. P6.
Okay, that sounds good. Ismail?
Tomorrow.
Okay, good. So let's do it tomorrow, but with the condition that first of all, I will check your homework. You have to show me your pages on the screen like this, or I will ask you to share your screen, your pages on the screen. And if I find that all you guys have gone through example number 1, 2, 1, 2, 3, 4, 5, completely, thoroughly, right? And then we'll start
sir.
tomorrow. First, I will check your homework and then I will start this one. Don't disappoint me, guys.
Sir.
Don't like if I will be upset. So please don't disappoint me. I can do this thing tomorrow as per your request. That's fine. No problem with me. But you need to go through example number 1 to 5 thoroughly. You have to show it to me, your pages. You have to share it to me, share with me. Okay. And then we'll go for example 4. If you are not getting any of the points in the example, that's fine. But I just want how you have tried that example. I want to look at that part. Just try it. If you stuck at some point, leave it for me. I'll be there. But I want you to try first before you ask me. So first of all, example number 1 to 5 homework, you have to be done with the complete homework till 1 to 5. And then after we will start this article, last article, and day after tomorrow exam. So let's stop here, guys. I don't mind. May I stop sharing this screen to you? We'll continue this thing tomorrow, okay? Okay, guys, any question for me in this chapter?
No, sir.
Nina? Alex? Okay, so all you guys are, oh my gosh, it's just 11, right? That's fine.
Yes, sir.
Yep.
We're
Queen Heart, are you good?
Yes, sir. I'll know once I get some practice in.
Yeah.
And
This
we'll go
requires-
tomorrow morning.
I can understand this requires some practice. Yeah, everyone requires practice. Okay, guys, so no questions. I'll see you tomorrow tomorrow at 10. What time you want me to see tomorrow? 10 or quarter to 10?
Is it 9:45 or 10?
9:45.
Doesn't matter to me.
So
Yeah, I mean,
tomorrow at 9:45. Okay, guys?
All right.
Okay, see you guys. Take care. Take rest.
Look at this, sir.
You too, sir.
Stay healthy and work hard.
See you tomorrow.
See you tomorrow.